In this next lesson, we are going to look at the inequality relationships that exist inside of one triangle. We're going to begin here with the corollary of the exterior angle theorem. Now, if you remember the exterior angle theorem, it stated that in this diagram here, that angle 1 is congruent, or the measure of angle 1 is equal to the sum of the measures of the two remote angles. So, using inequalities, the corollary of the exterior angle theorem would state the measure of an exterior angle of a triangle is greater than the measures of each of the remote interior angles. And if we look at it from an inequality point of view, if measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3, and all three of these have to be greater than 0, otherwise we wouldn't have a triangle, then the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. That is what this corollary is telling us. So, using that and the diagram that's shown here, why is the measure of angle 5 greater than the measure of angle C? Well, if we look, angle 5 is exterior to triangle ACD. And by that, the measure of angle 5 is equal to the measure of angle 3 plus the measure of angle C. Then, invoking the corollary of the exterior angle theorem, we can say, therefore, the measure of angle 5 is greater than the measure of angle C. So again, a corollary is a conclusion that can be drawn easily from a theorem or postulate, and this one works out just this quick and simple. So along with this item, we can also look at other theorems that come in with the inequalities, particularly those that relate to angle measurements and side lengths. So let's take a look at these, or first and second. Theorems 510 and 511. Theorem 510 states, if two sides of a triangle are not congruent, then the larger angle is opposite the longer of the two sides. A little bit of a miss there, forgot the T. Larger of the two sides. Theorem 511 goes along with this. It states, if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So it's kind of like a converse of the previous statement, but we're looking at it from the angle point of view instead of the sides. So given the diagram that is shown here, triangle SOX, and the angle measurements that are stated, you need to put the side lengths in order from shortest to longest. First thing we need to do in this process will be to find the measure of angle X. So knowing our triangle angle sums theorem, that the measures of all three angles has to equal 180. The two angles that are already provided, 130 degrees and 24 degrees, their sum is 154. If we subtract that from 180, we will come up with 26 degrees, and that will be the measure of angle X. So angle X is 26 degrees. Now, invoking theorem 511, the shortest side will be opposite the shortest angle, so we will have line segment OX is less than line segment, next would be opposite the 26 degrees, so SO, which will be less than opposite the 130 degrees, is line segment SX. So this would be the order of the line segments based on theorems 510 and 511. Now we also have one more theorem with inequalities of a single triangle we're going to look at in this lesson, and that is theorem 5, which is called the triangle inequality theorem. And this one states the sum of any two sides of a triangle must be greater than the length of the third side. And the reason for this is that if I had a triangle that had a side length of 8, a side length of 2, and a side length of 4, that the 2 and the 4 would not be long enough to reach each other. They would fall down and land on the 8 with a space in between them. So we have to have any two sides longer than the third. So with that idea in mind, could we build a triangle with the following side lengths? How about 2, 6, and 9? So to begin this, we say is 2 plus 6 greater than 9? Well, that's 8 greater than 9. The answer is no. So right away, we cannot construct a triangle from these side lengths. Let's take a look at another trio. What if I were to make it 4, 6, and 9? So let's begin again. Is 4 plus 6 greater than 9? That's 10 greater than 9, and yes, that checks out. So how about 4 plus 9 greater than 6? Well, 4 plus 9 is 13. 13 is greater than 6. That checks out. Last is 6 plus 9 greater than 4. Well, both 6 and 9 individually are greater than 4, but 15 greater than 4. That checks out. So yes, these three side lengths could be, or these three lengths could be used for the sides of a triangle. So a lot of inequality theorems came in here and play for one triangle. Make sure you have them down and are ready to use them.